Let us start classes of IP address. In this lecture, we'll discuss the 5 types of IP address classes. We will also see in detail what do these classes mean and how to guess the class of an IP address just by looking the numbers. IP address is an address having information about how to reach a specific host, especially outside the LAN. An IP address is a 32-bit unique address having an address space of 2 raised to 32. Generally, there are two notations in which IP address is written: dotted decimal notation and hexadecimal notation. Some points that need to be noted about dotted decimal notation are that the value of any segment is between 0 to 255, as we have discussed in the previous lecture, and there are no zeros preceding the value in any segment. For example, if the number is 054, it should be written as 54. So, why classes of IP address are important? The 32-bit IP address is divided into 5 subclasses, as you can see on the screen. These are class A, class B, class C, class D, and class E. Each of these classes has a valid range of IP address. Classes D and E are reserved for multicast and experimental purposes respectively. The order of the bits in the first octet determines the class of an IP address. IPv4 address is divided into two parts: network ID, that is net ID, and host ID. The class of IP address is used to determine the bits used for network ID and host ID. Each internet service provider or network administrator assigns IP address to each device that is connected to its internet. Note that IP addresses are globally managed by the Internet Assigned Numbers Authority (IANA) and Regional Internet Registries, that is RIR. While finding the total number of host IP addresses, two IP addresses are not counted and are therefore decreased from the total count because the first IP address of any network is the network number, whereas the last IP address is reserved for broadcast IP. Let me repeat this sentence once again for you. If you want, you may note down because this is very important. So here it goes. While finding the total number of host IP addresses, two IP addresses are not counted and are therefore decreased from the total count because the first IP address of any network is the network number, whereas the last IP address is reserved for broadcast IP. Now let us move on to the first class, which is class A. IP addresses belonging to class A are assigned to the networks that contain a large number of hosts. The network ID is 8 bits long, whereas the host ID is 24 bits long. The higher order bit of the first octet in class A is always set to 0. The remaining 7 bits in the first octet are therefore used to determine the network ID. Therefore, the total number of network IDs is 2 raised to 7, which is equivalent to 128. The 24 bits of host ID are used to determine the host in any network. The default subnet mask for class A is 255.x.x.x. Now you may have a question, what is a subnet mask? Don't worry, we are going to talk about subnetting and subnetting masks after this lecture. Note that 0.0.0.0 and 127.xyz are special addresses, as we have discussed a couple of minutes before. The next is class B. IP addresses belonging to class B are assigned to the networks that range from medium-sized to large-sized networks. The network ID is 16 bits long and the host ID is 16 bits long. Higher order bits of the first octet in class B is always set to 1, 0. Therefore, there are 14 bits remaining which are used to determine the network ID. The 16 bits of host ID are used to determine the host in any network. The default subnet mask for class A is 255.255.x.x. Since 14 bits are used to determine the network ID, total number of network ID is 2 raised to 14 and total number of host IDs is 2 raised to 16 minus 2. Now why minus 2? We have already discussed in the previous slide. The next one is class C. IP addresses belonging to class C are assigned to small sized networks. The network ID of class C is 24 bits long and the host ID is 8 bits long. Therefore, there are available hosts are 2 raised to 8 minus 2, which is 256 minus 2, that is 254 host IDs are available for class C. The higher order bits of the first octet of IP address of class C are always set to 110. The remaining 21 bits are used to determine network ID. The 8 bits of host ID is used to determine the host in any network. Therefore, the default subnet mask for class C is 255.255.255.x. The fourth class is class D. IP addresses belonging to class D are reserved for multicasting. The higher order bits of the first octet of IP address belonging to class D are always set to 1110. The remaining 28 bits are used to determine network ID. The 28 bits of host ID are used to determine the host in any network. Therefore, total number of network IDs is 2 raised to 28. Finally, moving to the last class, that is class E. IP addresses belonging to class E are reserved for experimental and research purposes. IP addresses of class E range from 240.0.0.0 to 255.255.255.254. This class doesn't have any subnet mask. So if anyone asks you which class doesn't have any subnet mask, the obvious answer is class E. The higher order bits of the first octet of class E are always set to 1111. So I hope you are clear with all the classes. If you are not clear, you can always rewatch the videos again. So here is a quick recap. It's a quick table for the classful IP addressing. So as you can see, for the class A, the start address is 0.0.0.0 to 127.255.255.255. In the same way, you have to remember this table, and therefore you can see class B starts from 128.0.0.0. Class C starts from 192.0. Class D starts from 224.0. So suppose someone gives you an example. Let's say I'll take a random address 128.52.56.123. So if anyone asks you to which class this address belongs, you may say the first bit is the first octet is 128. So for sure this IP address belongs to class B. In this way, just by looking at the numbers, you can guess the class of IP address.